Okay, so in the last session, we discussed about functions in C programming language. What is a function and what are the important properties of a function? What are the different categories of function? How to define our own function, which is called a user-defined function. And we have seen few examples like how to calculate a area using a function, how to calculate a factorial using a function, and then how does the function communicate with each other. So a function is a set or a block of statements which is written to complete a specific task. And for function communication, the idea is simple that whenever you have any problem, whenever you have any bigger program, so you divide that problem or the program into smaller sub problems. And for each sub problem, then we write one function. So, for example, if your problem is divided into 5 sub problems, so we'll be writing 5 functions for those 5 sub problems, and finally we'll be having one main function. So that main function would be coordinating or communicating with the remaining 5 functions, and will solve the entire problem. Okay, so that is called modular approach. We divide the problem into multiple modules, and then for every module we write one function, and then the functions communicate with each other, and then they solve the problem. Function communication is nothing but making a function call. So from the main function, when you call another function, so we simply say that the two functions are communicating with each other. Okay, and we have seen one more important thing, that when a function call is made, so basically a program control is transferred from that point to the point where the function is present. It executes that function step by step or statement by statement. Once the execution of the function is completed, the moment a return statement is encountered inside the function, then the program control is transferred back to the point from where it came. Okay, so this is important, that how does the program control transfer is done from one point to another point, then that part of a function is executed, then it comes back. And we have also seen that in C programming language, the program execution always starts from the main function. I repeat, the program execution always starts from the main function. And the program compilation starts from the first line of your program. So the program compilation starts from the first line, but the program execution starts from the main function. That you always need to remember. I hope you are able to see my screen. I have shared my screen, so someone should reply me whether the screen is visible or not. Yes, it is visible. Thank you. Now, today we'll be starting with the basics of data structure. We have seen the required part of C programming for data structure very briefly. Like we have seen arrays, we have seen structures, we have seen how to use those data structures, that is array and structure in C. Then we have seen how to write a user-defined function. Now after this, we are in a position to start our data structure part, and today we'll be starting with that. We'll see the introduction of data structure and the basics of data structure. So your syllabus, your revised syllabus is available into the data structure folder of your classroom. So I hope you must be seeing that part, because it has all the updated things with your session recording links, and then your session programs and explanations. So please keep on visiting that. So if you see the syllabus of the data structure, the first part or the first module is introduction to data structure. And what I do, I go to your classroom page. This is your classroom page. And when I go to the classwork, and inside the data structure, now this is data structure. So you have session 3, then session 2 video link, session 2, and then DS syllabus. Syllabus is there. Okay, so this is your syllabus. And if you see, then the first module is your introduction to data structure, in which we have introduction to data structure, concept of ADT, types of data structures, that is linear, non-linear, and then different operations on data structures. So let's start with the basics of data structure. So the first thing comes into our mind is what is data structure? Hmm. As the name suggests, a data structure is basically structuring a data. Now, when we say structuring a data, so what does it mean? What we are talking about here, where we need to structure data. Now, we have seen that when we give any instruction or any task to the processor to complete, to do, so the processor gets all its data, all its instruction from the memory. So memory is the area from where the processor is taking all the data and where the processor is putting or writing or storing all the data. Okay? So your memory is the main part. Now memory is a storage unit where your data, your program, your functions, your code, everything is stored. So everything is stored into the memory. When I say memory, I mean to say RAM. I repeat, when I say memory, I mean to say RAM. So RAM is the storage unit or it is a memory wherein your entire data is stored. Okay. Now, when our entire data is stored into RAM, let me start. Now, when in the memory, everything is stored. So, it is important that how do we manage that memory or how do we structure our data into the memory. Okay. So, in a very basic way, your data structure can be defined that it is a way of storing and organizing the data into the memory so that it can be accessed efficiently. So this is a basic definition of data structure. It is a way of storing and organizing. It is a way of storing and organizing the data in the computer memory so that it can be accessed efficiently. So that it can be accessed efficiently. So same example which we have discussed earlier, that when you have a classroom, so imagine that your classroom is your memory, is your RAM, and then the benches which we are keeping in your classroom so that you people can sit, those benches are basically the organization of your classroom, how your classroom is organized or how your classroom is structured. Okay. Now, when you changes the way you are keeping the benches in the classroom, you changes the way a student can sit and can move out of the room. Okay. For example, when we keep a space in between the rows of the benches, so it's quite easy for any student who is sitting inside to come out because only one student need to move out and then the inner student can come out. But imagine that you are not keeping a spaces in between the rows, and all the rows are, or all the benches of multiple rows are touching each other. So there is no space in between. So what happens that if we have 5 benches and all those 5 benches of first line are touching each other, they are like there is no space in between them. So on 5 benches, 10 students would be sitting. Now, if any student, any inner student need to come out, then all the students need to move out. So for example, if there is only space over here after 5 benches, all the 5 benches are touching each other and the large bench is touching the wall. So there is a space only after the 5 benches. Okay. So what happens कि अगर पहले स्टूडेंट को बाहर निकलना है तो he can directly move out. दूसरे स्टूडेंट को निकलना है तो पहले स्टूडेंट को निकलना पड़ेगा. तीसरे स्टूडेंट को अगर निकलना है तो first two students need to move out. Likewise, if the last student who is sitting at this corner need to come out, so in this case उसके पहले के जो all 9 students है they also need to move out and then only this student can come out. Okay, so now what's happening, the moment you change the organization or the structure of your classroom, then the student sitting in and coming out, this is something like accessing a student. तो जो student का जो access time है, this is changing. So depending upon the structure of your class, the student access time changes. Exactly in the same way, depending upon the structuring of data in your memory, the access time of the data also changes. Okay, for some structure, the access time is better as compared to different structure. Okay, and at the end of the day, what we need, we want to do the things as fast as possible. We want our program to get executed as fast as possible. Likewise, we want to access the data as quickly as possible, as fast as possible. Okay, and that's why we study this subject. This subject is all about how you can structure your data, how you can store your data inside the memory so that it can be accessed efficiently. Efficiently simply means that you should be in a position to access it easily. You should be in a position to access it quickly. I repeat, you should be in a position to access it easily and you should be in a position to access it quickly. That is called efficient access. Okay. So a data structure is a way of storing and organizing a data inside your computer memory so that it can be accessed efficiently. Okay. So that is the basic thing of a data structure. Now, the second point is abstract data type. It is also called as ADT. Now, let me tell you very clearly, there is a difference between abstract data type and abstraction. There is a difference between abstract data type and abstraction. Abstraction is a process, abstract data type is not a process. So, what do you mean by word abstract? What does it mean? Please, anyone? What do you mean by the word abstract? Yes, you can reply into the chat box. Not existing in reality. Okay, invisible. Invisible. Okay, invisible is a better word or the closer word you can say. Abstract word basically means hidden. Okay, if the things are not clear, if the things are hidden, then it is called abstract. So abstract data type, some sort of hiding comes over here. So your data type is hidden or you are hiding your data type, something like that. Okay. Now let us see what is an abstract data type. An abstract data type is no need to get confused with these terms. It is a mathematical model. It is a mathematical it's a mathematical, or you can even say logical model. Logical model which is used to specify which is used to specify the data and the operations that can be performed on that data that can be performed on that data. So very simple definition of abstract data type. It is a mathematical or a logical model. Okay, mathematical or a logical model. So something like on paper, in terms of some specification, in terms of some blueprint. Okay, so it is like a blueprint, or it is some specification written on paper, something like that, which is used to specify. What does it specify? It specifies two things. One is the data which can be stored in that abstract data type, and second, the operations that can be performed on this data. Data that can be stored or that can be held by that data type, and second, the operations that can be performed on this data. Okay, so combination of these two things is basically your abstract data type. Fine. So in short, I can write ADT equals to, this is just for understanding, huh? ADT equals to data plus operations. Okay. So what is ADT? It is a data plus operation. This is for understanding, so that you can always remember it. But if someone asks you, okay, what do you mean by ADT? How do you define an ADT? So you should say it's a mathematical or a logical model which is used to specify two things: the data and the operations that can be performed on this data. Okay. Take an example. Example of your integer ADT. You want to write a ADT for integer. So what you will be thinking? You will be thinking about two things again: the data that can be stored into this abstract data type of integer, and then the operations which are possible on this data. So if you think of integer ADT, abstract data type for integer, so under data part, what can you have? You can have any whole number. You can have any whole number. कोई भी number आपका हो सकता है minus infinity से लेके plus infinity तक. But that should be an integer number. It cannot be a real number, or it cannot be a floating point number. Okay, so any number from the range minus infinity to plus infinity. Now this is theoretical, because abstract data type is a mathematical or a logical model. It is not implementation. So since it is theoretical, so we can say minus infinity to plus infinity. Any integer number in the range minus infinity to plus infinity, that becomes a data part for ADT integer. And then the operations, all the possible operations that can be performed on a integer data. For example, you can perform addition of two integer data. Okay, so addition is one operation. Subtraction, you can subtract two integer values. You can divide two integer values. You can multiply two integer values. Okay, so all these are the operations that can be performed on this data. I repeat, these are the operations which can be performed on this data. So addition, subtraction, multiplication, division. For example, these are the basic four operations that can be performed on integer data. So my data part is minus infinity to plus infinity. Let me write here. Example. Integer ADT. So for integer ADT, what is the data? What is the data part? Any integer number, any integer value or integer number from minus infinity to plus infinity on paper. Otherwise, we write it as how to have that minus infinity. I put a dot, then comma, minus 1, comma 0, comma 1, comma 2, comma dot. Okay, so this becomes a data part for the integer ADT. And then for operations, what you have, you can perform addition of two integers. You can perform subtraction. You can perform multiplication. can perform division and so on. Okay, so these are the basic operations that you can perform on integer ADT. Okay, so this is the example of ADT, a data part. जो भी आपको ADT define करना है. Now again I am saying you ADT is on paper specification. So this is something like you have a programming language or you are writing in programming language and you want to decide for data type. So before implementing a data type into the programming language or before adding a new data type into the programming language, you will be writing it on paper. क्या भाई ये data type होगा कैसा, इसके अंदर डेटा क्या होगा, इसके ऊपर क्या क्या ऑपरेशन परफॉर्म होंगे. So that on paper specification of a data type is called abstract data type. I repeat, that on paper specification of data type is called abstract data type. The moment your on paper specification is implemented in the programming language, at that moment the abstract word is removed from abstract data type and what remains only data type. Okay, so for example in C programming language, the implementation of integer ADT is your int data type, int data type. So int data type is the implementation of integer ADT in C programming language. Likewise, the float data type is an implementation of float ADT. So this way you can think of okay, abstract data type is on paper specification of your data type. The moment this on paper specification आपने decide कर लिया पेपर के ऊपर कि आपके डेटा टाइप में क्या क्या डेटा स्टोर हो सकता है, क्या क्या डेटा आ सकता है, फिर उसके बाद में आपने ये भी डिसाइड कर लिया कि इसके ऊपर कौन कौन से ऑपरेशन पॉसिबल है, कौन कौन से ऑपरेशन आप कर सकते. The moment you implement this on paper specification in programming language, the moment you implement this in the programming language, so this is now available as a data type with you. It is not abstract, it is not hidden. So that abstract word is removed. So ये abstract data type में से जैसे आपने abstract word निकाल दिया, so what remains? Only data type. Okay, so what remains? Only data type, because that is the concrete implementation. That is the concrete implementation. आपका पहले abstract जो था, जो hidden था data type, वो on paper था, आपने जैसा उसको programming language में implement कर दिए, now it is available as a data type. So that abstract word is removed from it and only remains your data type. So int data type, float data type, char data type, double data type, and so on. Okay, so all these data types are available as a implemented data type. But before implementation करने के पहले आप जब उसको on paper लिखते हो, आप जब उसको on paper specify करते हो, so that on paper specification of a data type is called abstract data type. Okay, so I hope this is clear to you. Yeah, what do you mean by abstract data type? Again, it is a mathematical or a logical model which is used to specify the data and the operation that can be performed on that data. So the way you have an example of integer ADT, the same way you can have the example of other data types. And when we will be learning the different data types in various modules, that time we will see what are their ADTs, उनका ADT क्या है. Now the next point is data structure types or types of data structure. Now all data structures are basically categorized into two types. आप किसी भी data structure की बात करो, so they are categorized into either linear data structure or non-linear data structure. So you think of any data structure, that data structure would be either a linear data structure or it would be a non-linear data structure. Now let's see what do you mean by linear data structure and what is non-linear data structure. Now, so this is a linear and a non-linear data structure. So here you can see in linear data structure, every item is related to its previous and next item. Okay, data is arranged in a linear sequence. Data is arranged in a linear sequence. Now this is important. In non-linear data structure, data is not arranged in sequence. Now this is a basic important difference between linear and non-linear data structure. In linear data structure, linear means in sequence. So in a linear data structure, the data is arranged in a sequence. The best example is your array. Okay, so your array is your linear data structure. So all the elements of the array are linearly sequenced. Okay, so data is arranged in a linear sequence, and in a non-linear data structure, data is not arranged in sequence. This is the first basic difference. Second, data items can be traversed in a single run. So when you talk about linear data structure, we will see when we'll be learning different linear data structure, you can traverse or you can visit all the data elements, or you can access all the data items, data elements in a single traversal. We'll see what do you mean by the traversal, data structure traversal later on. But now you just need to remember कि single traversal में आप सभी data elements को access कर लेते हो in linear data structure because it is linear in sequence. Okay, and in non-linear data structure, all the data elements cannot be accessed in a single traversal. वहां पर आपको multiple traversal करना ही पड़ता है. Okay, so there you need to traverse in a multiple way or multiple times to access all the data elements of the data structure. But in linear data structure, you traverse only once, you visit all the data elements only once, and you get all the data elements. Okay. Examples of linear data structure: arrays, stack, queue, linked list. Example of non-linear data structure: tree and graph. So basically, these are the different modules which we are going to study. The second module is stacks, then queue, then linked list, then trees, then graph, and last one is your searching technique. So your tree and graph, these two data structures are non-linear data structures, and remaining your arrays, stack, queues, linked list, all these data structures are your linear data structure. Linear data structure implementation is easy. Non-linear data structure implementation is difficult. Now let's come back to first point. In linear data structure, if you see carefully, every item is related to its previous and next item. So since it is in linear, all the data elements are in linear fashion. They are stored or they are kept in a linear fashion. So if you think about any intermediate element, so this intermediate element is connected to its previous element also, and it is connected to its next element also. Take an example of an array. So if you got an array of say 5 elements, and if you think of the middle element, which is available at the index position 2, indexing always starts from 0. So at index position 0, you have the first element, index position 1, second element, index position 2, third element, index position 3, fourth element, and index position 4, fifth element. So your middle element is present at the index position 2. Okay, A of 2, if the array name is A. So now this element A of 2 is connected to its previous element A of 1 and is also connected to its next element A of 3. So this is how the data elements are sequenced in your linear data structure. But the same is not true for your nonlinear data structure. So if you see the nonlinear data structure part, what it says, every item is attached with many other items. So in linear, since it is linear in nature, so one item, one data element is connected only to the previous element and to the next element at the most. If it is the last element, then it is connected only to the previous element. If it is the first element, then it is connected only to the next element, because there is nothing before the first element and there is nothing after the last element. Okay. But in case of non-linear data structure, if you see, then if you talk about any data element, so one data element is connected to multiple data elements, not only to previous and not only to next, but it can be connected to multiple. So you just try to visualize a map of a cities or a map of anything. So a map of cities, if you visualize a map of a city, you must have seen Google Maps many times. Okay. So if you see that, So all cities are connected to multiple cities. You may find it that one node, one city is connected to multiple. So that's the best example of your non-linear data structure. And that is basically implemented in the form of graph. So a map is something like a graph. Then linear data structure is something like a linear data structure is something like a graph. So then linear data is arranged in a linear sequence in a linear array, stacks, queues, linked list. For example, you need to remember. And non-linear data structure, only two examples you need to remember: trees and graph. So trees and graph are non-linear data structure. Array, stack, queues, linked list are linear data structure. It is very easy to implement the linear data structure, and it is little difficult to implement the non-linear data structure. So this is the difference between a linear data structure and a non-linear data structure. And these are the two categories, two main categories of your data structure. So first you have a data structure, then you have linear data structure, then you have non-linear data structure. Under your linear data structure, you have array, you have stack, you have queue, and then you have linked list. Okay, so four examples you can write under your linear data structure. Under your non-linear data structure, you have only two examples. One is your tree, and second is your graph. So trees and graph are the examples of your non-linear data structure. Okay, and these are the different differentiation points of linear data structure and non-linear data structure. Operations on data structure. So there are I don't know, but the connection was lost. Okay, so we are again into the session. Like, I am again into the session. What point we were discussing? May I know? Any one student can say it. Uh, Operations on data structure. I think I was explaining the dictionary, yeah, how the data is stored into the dictionary. Am I right? No. Linear and non-linear data structure. Okay, so linear and non-linear data structure, I think the explanation was done, and this were the references. If you can see, the screen is still visible now. Screen is not visible. I hope it is visible now. Okay, fine. So this were the references which we were talking about linear data structure and non-linear data structure. So all differences were explained. Yes, I have explained all the differences. So yes, okay, fine. That is done. So no need to explain it again. But just to remind you, linear data structure, all the data elements are arranged in a linear sequence, and non-linear data structure, they are not arranged in linear sequence. Then data structure divided into two categories: linear data structure, non-linear data structure. Linear, array, stacks, queues, linked list. Non-linear, trees and graph. Okay. Then operations on data structure. I was talking on operations on data structure. So the basic operations on data structure is to read the data element from the data structure, is to write into the data structure, is to display the content of the data structure, and to traverse the data structure. Okay. So reading a data structure, writing into a data structure, then displaying the content of the data structure, and then traversing a data structure. Now, depending upon the data structure, few more operations can be there. For example, if it is a stack data structure, so you have the operations like push, you have the operation like pop, then you have peek, then you have display, then you have operation like is full, then you have operation like is empty. So these are the different operations that we have on a stack data structure. So the way you have different data structure, more operations can be added depending upon the data structure. But the very basic operation that can be performed on any data structure are four: reading the data structure, writing into the data structure, displaying the content of the data structure, then traversing a data structure. So four basic operations on any data structure. Then coming back to this point, data structure, it is a way of storing or organizing the data into the memory so that it can be accessed efficiently. The best example is dictionary. So I was talking on dictionary. If you imagine dictionary, so in dictionary, what you have, a word and its meaning, then word and its meaning, word and its meaning, word and its meaning. So word and its meaning, ये दोनों combine करके एक data element हुआ. Then another word and its data element. Another word and another. You have thousands of words, you have lakhs of words into the dictionary. So you can imagine there are thousands or lakhs of data elements into this data structure of dictionary. Okay. Now, how these data elements are kept into this dictionary, this is very important. ये जो how है ना, HOW, how the data is stored, how it is kept, how the data elements are kept into the dictionary, this defines the access time, how quickly you can search. Now imagine that all the data elements, all the words in the dictionary, they are stored in a sorted order. They are stored in a sorted order, and that's the reason we can very quickly search for a given words meaning. किसी भी word के meaning को हमको देखना है तो हम उस word को एकदम quickly search कर सकते हैं. Why? Because they are in a sorted order. Imagine they are not stored into the sorted order. अगर sorted order में stored ना हो, किसी और order में अगर stored हो, then it would be so difficult to search for a specific word meaning. किसी भी specific word के meaning को देखने के लिए उस word को हमें search करना पड़ेगा. So it would become so difficult to search for a specific word if they are not stored in a sorted order. And that's why this word is important, efficiently, so that it can be accessed efficiently. So you need to always store the data into your data structure, or basically your data structure should always be organized in such a way in the memory that the data element can be accessed efficiently, as quickly as possible. Okay, so that's all we are going to store. We are going to learn into this subject, into this course. Okay, what are the different ways of storing the data into the memory in the form of different structures? What are the different operations that you can perform? You can perform on different data structures and so on. Okay. So we stop here today. Let me share the attendance form with you people. Now, in your attendance form, there is one change. What was happening that few of you people were not entering your roll number properly. So, because of that, I was facing a lot of issues when I was compiling the attendance. So now what I have done, that I have added your roll list into this form itself. So you only need to select your roll number. Okay. So that will be easy from your side, and that would be easy from my side also. So I have shared the attendance form. Please go there, fill up your attendance, and do not